Welcome to Mathematics Lecture Series. Our topic is Concept of Limit. This is lecture number 10 and Applied Calculus series. Before the start of lecture, I request you kindly subscribe the channel and like the video and also share the video. Observe that uh, that graph to understand the concept of limit. As on x, this is x-axis and that one is a y-axis. On x-axis, if x approaches to infinity in positive sides, then what about this red line? Red, this is f of x basically. This approaches this real number L, positive real number approaches to L. So we can say that limit x tends to infinity, f of x is equal to L. Another example to understand the concept of limit, to observe this graph, as you see that as x tends to plus minus infinity, x axis plus infinity and here is the x axis minus n. What about the f of x? F of x goes to 0. Touches the x axis means it will become 0. What about that? It is also goes to 0. So f of x goes to 0. You can see that okay, and observe that if x tends to 0, x tends to 0, if x-axis goes to 0, what about that graph? That graph f of x goes to plus minus infinity. The plus infinity minus infinity, this is goes to uh, plus infinity and that goes to minus infinity. So another uh, definition of limit, concept of limit. Consider a circular disk, any circular disk with the area of 1 unit. If we remove half of the disk, area of the remaining part is 1 by 2. If further remove half of the remaining, then what is the area? Leftover part is 1 by 4, or we can say 1 by 2 square. By further removing half of the remaining disk, then what is the area? Of course, you can say that 1 by 8 or we can say 1 by 2 cube. Similarly, 1 by 2 half or more we cut the disk at 1 over 2 square, 1 over 2 till continue 1 over 2 power n, and it is goes to 0. So the area of the leftover parts gets smaller and smaller, ultimately it will decrease to 0. We describe this fact by saying the limit of leftover area is 0. More precisely, we say that the limit of the sequence number is 0. You can understand with a concept of this simple example. Another example, f of x square minus 25 over x minus 5. We find the limit at the point x is equal to, we will have the 0, which is a meaning quantity, but we can't cancel x minus because it is 0 and 0 with 0 couldn't cancel, so we cannot determine the value of f of x at x is equal to 5. But we do not leave the problem here, instead we try to evaluate the f of x when x is very near to 5, and this will finally lead us to value that would almost be the value of f of 5. Mean after cancellation, f of x plus f of 5 means x plus 5, we put the values in x plus 5. Thus we can have f of x at x is equal to 4.9 and our x is equal to 5.1. This technique is quite simple. Cancel x minus first, this is the perfect ledger as x is not equal to 5. Then substitute the value of x, for example for 4.99 in x plus 5. So 4.9 plus 5, 9 point, f of 5.0, 10.01. We now write down some of the values given to x and the corresponding value required by f of x in the following table. Observe that we from approaches from the left. X approaches 5 from the left. 4, 4.7, 4.9, 4.99, 4.999. Then what is the value of f of x into apply x square minus 5 over x5? We'll have the 9.799. It approaches to 10 if we x approaches 5. Similarly, if we approaches x approaches 5 from the right side, x approaches 5 from the right side, so 5.6, 5.35, 5.0 and 5.0 from the right side, we approaches, then we will have 10.001 at the point 5, 10.7, 10.35, 10.0 and 10. Both sides from the above table we note that as x gets closer to 5, f of gets closer to 10. Then what we can say? We can say the limit of s as x is 10. And we can write limit x tends to 5, f of x is equal to 10. This example leads us to informal definition of the limit. As f of x, L is any number limit, so f of x minus L mod is less than f, means f of x gets closer to L. Epsilon is any positive number, but it is very close to 0 or greater than 0. If whenever x minus a less than delta, means x closer to a, then we will have f of x minus a less than epsilon closer to L. In this case, we can write limit x tends to f of x is equal to L. So this informal definition, we can prove the two example. Limit x tends to 3, 2x is equal to 6. Here f of x, of course 2x by compare that, and L is equal to 6, limit is 6, and what about the a is equal to 3. So f of x minus L mod 2x minus L value is 6, so 2 is common, we have x minus 3. So by definition already we have x minus 3 is less than delta. Delta is any positive number but depend on epsilon. So here we apply 2 in that equation, equation 2x minus 3 is less than delta, so f of minus L is less than 2 delta. 2 delta is epsilon. So we verified by the definition, we have proved that limit x tends to 3, 2x is equal to 6, because from x minus 3 less than delta we will have the f of x minus is less than epsilon. Now another example, x square plus 2x plus 1, 2. F of x, this is a polynomial direct. If you apply the limit, you will have 6 by 3 are 2. So here limit is 2 f of x, x square x plus 1, and what about the a is a given limit, x a is equal to 2. Thus by definition f of x minus f of x a, so f of a minus L, so f of x we have the value, apply the value L, limit is 2, taking the LCM, so x square plus 2, here 2 multiply with x plus 2x minus 2x minus 2x plus 1, so 2 will cancel with minus 2, we will have x square minus 2x upon x plus 1, x is common, x minus 2 over x plus 1. So here we can write it also that in that way, x over x plus 1, x minus 2. What about this quantity x minus 2? X minus 2, in fact this is less than delta, and delta depends on epsilon. It is also a positive quantity. So this value applying that equation, f of x minus L mod x over x plus 1 x minus 2, we, if x minus 2 less than delta, so that is less than x over x delta, that is the value of epsilon. So we will have x minus 2 less than delta, and we will find f of x minus L is also less than epsilon. So that completes the proof, and we will have limit x tends to 3x square plus 2 over x plus 1 is equal to 2. Now, informal definition of the limit. Let the function be defined for all values of s set possible if our x is equal to a. We have a function f of x which is defined all positive values of x, but it is possible that it is not defined x is equal, where a is a real number. A is any real number. The function f is said to have limit L, a real number. L is any real number as x approaches a. If the value f of can be made as close to L, we please by taking a sufficiently close but not equal to a. In such case we write limit x tends to f of x is equal to a. What does it mean? If we take x closer to L, then f of x must be closer to L. Note that x may be close to a both from left and right of it. Sometimes limit x tends to a can be evaluated by calculating f of a also. This holds, for example, whenever f of an algebraic combination of polynomials and or trigonometric functions for which f of a is defined, for example. For example, a limit x tends to 3 is a polynomial. Just you put f of by the f of a means x replaces 3 will have the limit 3. Limit x tends is a polynomial. Apply x replace it, you will have 10, 2 into 10 minus 3 is 7. Limit x tends to 1 plus cos x, then you directly apply x with 0. So 1 cos 0 is equal to 1, then you will have 2. Limit x tends to minus 3x plus, you can also in that case apply x replace it minus 2. So 3 into minus 2 minus is plus 4x minus 2 plus 5 minus is plus 4 minus 2 plus 5 3. So you will have the limit minus 2 by 3. Some basic theorems on limit. Theorem 1, if limit x tends to f of x is equal to L if any number, if g of x limit is m, L and m are real number, then what is this is a sum rule. Limit x tends to f of s plus gx. F of x is limit L, f g of L limit m, so L plus m. So you can also write it separately by taking the limit to each function. Limit s tends to f of a plus limit s tends to a g of x. So this is a sum rule, difference rule, similar, very similar to sum rule. Limit x tends to f of s minus gx. So f of x limit L minus m, you will have the answer by just subtracting the limit. You can also give the limit to each of the function. Limit x tends to f of L minus limit x tends to f g of x. Product rule, limit s f of s, just you add the lim L m, add multiply the limits. You can also give the separately limits. Limit s tends to f of L, limit s tends to g of x. Constant multiple rule, if it is a constant, you can write k limit of f of s L. You can write a constant outside the limit extent as a constant, k belongs to real number. Quotient rule, limit x tends to f of x gx L over m. So limit x tends to a f of x, limit x tends to g of x. Here m must be not equal to 0. Power rule, power if m and n are integers, then is finite. Limit x tends to f of m over n. Here what is the limit L m over n, provided L is a finite. Identity function, if f is an identity f of s, then for any value of a limit sf, just you replace x with a. Constant function, if f is a constant, that is f of k, then limit is similar to that number, constant number. Limit x tends to f of x, limit x tends to a k. So if theorem number 2, if p of x is in polynomial n x power n minus 1 x a plus n, here a is or constant and x or a variable, polynomial n x in nth degree, Then what is the limit x tends to a? Just you have to replace x with a and a a naught. If p of x and q are polynomial q of x not equal to 0, then polynomial px quotient of the polynomial, just you have to apply the limit by the x, so p of a over q over a. As example, limit x tends to x cube plus, these are two polynomials, just apply the 1 plus 4 minus plus 5, 2 over 6, 1 over 3, just we have x replace with 1, so x 1 cube 1, 4 x square 1 square 4 minus 3, here x replace with 1, 1 square plus 5, 2 by 6, 1 by 3. Theorem 5, quotient of the polynomials applies only when the denominator of the rational function is not 0 at the limiting point a. If denominator is 0, cancelling common factor in the numerator and denominator will sometimes reduce the fraction to one whose denominator is no longer 0 at a. In that case, when this happens, we can find the limit by substituting a simplified fraction. Noted that it may be noted that almost every problem limit that involves indeterminate expression is 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, 1 and 1 power infinity, infinity raised to power 0. If involves expression, when such expression occur, we have to work out the given product to get some definite value. We shall show you in this coming example and theorems. Two more examples. Cancelling a common factor. Evaluate limit x tends to x square plus x minus 2x square minus 5 as by given in theorem 1. This is a polynomial fraction. We cannot just substitute x is equal to, if we put, then we will have a denominator 0 because it makes the denominator 0. However, we can factorize. Now we can factorize and denominator and cancel the common factor x square plus x minus 2. So take the x common, then by factorization you will have x plus, by middle breakdown system you will have x plus 2 x minus 1. Here take the x common, x, so x minus 1 will cancel, we will have x plus 2 over x. Now in that case, this reduced polynomial, if you put x is equal to 1, that is, then you will have no more 0 in denominator. Now just apply the limit. So limit x square, we will have x plus 2 over, just replace x with this limit, x is equal to 1, so 1 plus 2 over 1 is equal to 3. Now another example, x cube minus 8x square, limit x tends to 2, by applying direct 2, we will have a 0 upon 0 form, or in denominator we have the 0. So you may realize that if we suggest the denominator becomes 0, however we can factorize the numerator denominator and cancel the common factor we get. X square minus 2, we will have the factor x minus 2, and x square plus 2x plus 4. Here is x cube, so you understand that is x cube, not x square. I have written in by mistake. So x minus 2x square plus 2 is plus 4 by the formula a cube minus b cube. X square minus 4 by the formula a square minus b square, we will have x minus 2x plus 2, x minus 2, x minus 2 will cancel, you will have x square plus 2x plus 4, x plus 2x is not equal to 2. So this denominator not more be 0 on the given number true. So limit x tends to 2x cube minus x square, limit x tends to 2 here, x square plus 2x plus 4x tends to 2. Here is also you consider this not a 1 2. So this is a reduced fraction. Apply x, limit x is equal to 2, 2 square 4, 2 into 2 4, 4. Here x replace with limit 2, so 2 plus 2 4, 12 upon 4 it becomes 3. So limit of x tends to 2x cube minus 8x square minus 4 is equal to 3. Thank you. I request you kindly subscribe the channel to click bell icon and like and share the video as you find more videos.